Hello, people. I guess you guys have all seen tutorial videos on the statistic basics of machine learning, how to implement transformer from scratch, all those kind of videos, which is trying to teach you to go all the way from the bottom to the top. The bottom up approach is not really the most efficient way for you to get something out of value out of this AI independent research stuff. At the point when you finally get yourself ready for doing some kind of actual influential work, it is already probably too late. So today, what we are going to be talking about is a more realistic approach, the most efficient way to get yourself a jumpstart to the most up to date, the most relevant stuff at the moment, the hottest topic of the AI research community discourse. And since we are living in an era of social media, there is no other place to look at other than x.com. So if you have been looking at stuff from X or Twitter, you probably in the past 2 to 3 weeks has come over this new large language model called Deepseek version 3. A lot of people have a lot of discussion over it, and the main selling point of this particular topic, a particular project, is that the per token cost, training cost of this particular project is extremely low compared to all the others um, base large language model. So today we are going to take a look at this particular topic. And while we are taking the look of it at DeepSeek version 3, what I'm going to demonstrate to you is with just how little a basic understanding of just how little of a knowledge base you need, and with a proper approach, um, you can probably get to um, a quite practical understanding of a huge project like the DeepSeek project. And here we are going to just start. The only two piece of prerequisite information for this entire walkthrough video is that you probably have looked at the diagram and get a little bit of an idea of what the attention mechanism in the transformer paper at some general sense. Okay, you probably have to take a look at the code on the code level, just very briefly have an idea of the overarching code structure, and you probably have an idea of what an nn.module based um, neural network module looks like in practice, which you will learn. You probably have already learned while you are taking that overview on the transformer implementation. With that much amount of practice, we are going to go through all those external resources with the following principles. We're going to go through the resources with priorities, which means that we're always finding or looking for the most meaty part of the resource that we are looking at. And we are reading by comparison. Um, you all know, you guys will know what it actually means um, in the mid of this walkthrough. And the last point is you would jump into the code as soon as you can, which just means whenever you think you are onto something that is detailed enough, you should be checking out the code. Okay, so let's just start with this technical report of DeepSeek version 3. Um, it is a very long paper and is a very large project of a very large model. And we are not going to be honest, we're actually not going to read anything beside the abstract because everything we need from this huge model is that it is a mixture of experts model. And by applying the principles of priorities and knowing the fact that this is a sequel, a version 3 means that there is a version 2 and a version 1. We are going to trace back to the starting point of this entire project and to see what kind of mixture of expert model it started off with. So, following that logic, we will get to the paper of the very start of this project, which is Deepseek mixture of expert. And you can also just take a look at the abstract. But at this point, we're also only just going to look at the first two sentences. You can look downwards however you like, but the part that we are actually curious about is we already got to the starting point of this entire DeepSeek project. We want to know what what's the other project that has inspired the DeepSeek team to start off with their journey in this exploration of mixture of expert large language model. And by reading to the second sentence, we can already trace the source of that idea, which is G Shard. So we go all the way back to G Shard. And at this point, there is really no tracing back. Um, you can just you're also free to take a look at the entire paper however you want. You're already getting to a point which large language model barely become a thing. And also there is really no predecessors or a clear um, inspiration source of inspiration for this entire G Shard project, which correlates very closely to the idea of mixture of expert. You can always follow this literally and go all the way back to the mixture of models idea, but that doesn't really help in our case. This is probably the first official and the first one that kind of introduced the idea of applying mixture of experts to large language model to the general public. So there is at this point we have already traced all the way back to the origin of this entire chain of development in mixture of expert large language models. And at this moment, we're going to apply our first priority, our first principle, which is we should look at this thing when we have no other place to trace. We should look at it at the most meaty part. Always look at the most meaty part. And for most of it, if you haven't been reading a lot of um, machine learning papers, you might not be so familiar with this idea that the most meaty part of this entire paper and of most machine learning research paper is always going to be the largest diagram or the poster of this lengthy paper. So we're just gonna scroll down all the way down and try to find the actual diagram. In our case, since this is the paper of G-Shard is trying to introduce a new model architecture, we're looking for a diagram that actually looks that actually demonstrate what exactly the model architecture is. And here we are zooming in. If you have the prerequisite knowledge of what a transformer based model diagram is, you will find the left part very much familiar because that is exactly what it is in the transformer encoder architecture. And here in this figure, it pretty much captures the overview of this entire paper. Um, Comparing the part on the left and the second one to the left, you can see that every other feed-forward network module in the transformer encoder architecture is replaced with the module called MOE, which is mixture of expert. And it demonstrates what actually the mixture of expert generally, in a general sense, mean. It actually just means a bunch of feed-forward network applied at the same time with the control mechanism of a gating. of a gating submodule ahead of all of them. And another like very useful heuristic is that on probably the text, the part, since the diagram is the most meaty part that we want to focus on, um, the the writer of those papers also know that people will looking for, who reads the paper will be looking at this particular area uh, first. So there's a very large chance that the text around this diagram is also going to be very useful knowledge. And we are just going to take a look at that. This part, in this case, in the case of G sharp, text around the diagram basically just introduced to us what actually a MOE layer is. So it goes into a more detailed explanation of what this second diagram differ from the uh, bread and butter transformer encoder architecture. As we see here, there is a gate function which works over the input hidden space and outputs this bizarre sign. We do not have to know this sign to be very clear of this thing, and we just recognize this sign at the next sentence. It tries to explain the mechanism in that it is computed by a gating network and has non-negative for each expert, most of which are zeros, meaning the tokens that is not dispatched to that expert will be zero. And therefore, the token is dispatched to a very small number of experts. And the particular implementation of this um, expert mixture of expert is that it will be dispatched to at most two experts, and we will be checking this. It is already getting to the point that it's very specific, so we'll be using the principle, using our third principle. That's when you feel like you are getting to very specific stuff, you should actually go to the code to see the actual detail of that idea. So as soon as you feel that things are getting pretty much very detailed, you should try to go to the code. But we'll just keep that in our mind. We'll finish reading this paragraph. And corresponding entries of this vector produced by the gate module are non-zeros represent how much an expert contributes to the final network output, which means it is a weight. So as we'll get the idea that the tensor is basically masked to zeros. Um, so only a snippet is getting inputted into each of the expert, which is just a feed forward network. And we are, in our case of the G shard, we're using at most two experts at the same time, and the output of those experts will be scaled by the particular numbers that marked the part that gets inputted into those corresponding expert modules. They get weighted by those particular inputs and by doing a weighted sum of all the experts, we get the output of the mixture of expert layer, which it further explain and confirm what we have just said is a weighted average of the outputs from the selected experts. Since we're getting to the part that we said we should be looking into the code to verify our idea in a kind of a specific way, we're just going to jump into a random. This is not actually random. This is the first implementation of the G shard uh, project. If you just Google for G shard implementation, this one is actually the first one that will pop up, and we will take that as a valid source of implementation. So as we scroll down, we still here the idea that we should be applying um, it, the idea that we should be going through external resources with priorities, which means we should always looking at the most meaty part of our current resources, not only applies to the paper, but also applies to the code base. So by reading this, and this is also the reason why I emphasize that you need to have some kind of an overview of what an NN module based um, modular neural network architecture look like. Since we're going to look for the most meaty part of this NN module based um, neural network modules, we want to look at the very top level, which in our case is not the expert class, but the entire MOE module. So we can see here, we can verify our idea in the forward function, which you can discard pretty much what actually you do not understand or you don't know for sure, and verify them later by like copy pasting the codes that you do not understand into ChatGPT to check out if your idea is right. But we're just gonna do pretty much ignore the parts that is not the most obvious um, when you're taking a first look at this piece of code. We can see here that you do a reshape and you go to the tensors go into the gate, and the after the tensor get processed by the gate, it will be sent into the experts. And that verifies with the idea that gets described here, what exactly the feed-forward network work is about. And then we're going to look just from like a top-down approach. After taking a look at the very top level, we're going to go into um, the the next top level, which is the gate and the experts. And in this case, we wanted to see how exactly is this sorry two experts work, and how does the gating work. So we're going to see that also by applying the same principle that you can just pretty much just ignore the part of the code that you are not so sure or do not understand and verify them later, you shouldn't really interrupt uh, this process of getting the overview. You shouldn't be focusing on those detailed what exactly do every single line of it do, but you should just try to verify the overview you just obtained from the paper as some at a certain practical level, but not too detailed in the code base. As we see here, our idea of a one hot vector for one gate and for another gate is demonstrated in the code base. And if you take a look at, and also there is a cumulative sum. And for mask 1 and mask 2, if we take a look at the other top level submodule, the expert module, you can see that actually uh, the way is kind of a cut down, like a minimized version of this mixture of expert module architecture mentioned in the paper. It actually only implements two experts, just two feed-forward network. So it is not that much a complete demonstration of the paper, but we get the gist of it. So the idea of a G shard is that it replaces a feed forward, every other feed forward network module of a transformer encoder to a bunch of feed forward network that guard is gated by a gating module and added up later on after the feed forward network output in a weighted fashion. So taking that idea and the very part on the right is just the part that talks about how cross-device distribution of these modules work, and which is not a huge part of our concern in this learning process. And as I said, if you have any confusion in the detailed code in the code base, you should really be dropping those line of code into ChatGPT directly, and it will just most of the time output a very solid response. In fact, what I have done here is you just drop the entire top two gating part, and one single line of describing what actually uh, you want from this code block, and GPT will just do its best in describing what actually happens. So we have already an overview of what the G sharp module is look like. Then we're going to go back. We're trying to apply our second line of principles is reading by comparison. We know that the DeepSeek MOE model is somehow a step forward upon the G sharp G sharp paper. So we're going to try to read in comparison by comparing um, which part does DeepSeek MOE attempted to improve over the G Sharp project? And again, after applying that principles, we're going to apply the principles of priorities again in this new paper, in that we are still seeking for the most meaty part of the entire paper. And in this case, it is still going to be the diagram. And by comparing, so we still read from left to right, and we see here this diagram is pretty much the same with what the G sharp diagram presented here. In that the only different part is that the router, the gating module gets to be called a router here, and there is also like two additional yellow line indicating probably there is a weighted amount get to be applied on this summation, which is also mentioned here, but we are not so sure of whether it is the same weighted mechanism. But that doesn't really hurt. It's almost exactly the same. And that is called what they refer to as a conventional top two routing, which is just G sharp. And the second this part B of this entire diagram is just they double the amount of feed forward network, they double the amount of selected experts, and they also double the amount of the yellow lines, the potential additional weighted um, parameter for each expert. But it's not, it's still the same. It's just double everything. And this is the part that actually DeepSeek MOE differ from the conventional approach or the G-shard approach, in that we can see from the diagram it has a separate pointer, which means a copy of the tensor sent into what it called as a shared expert, and that expert also do not participate in the weighted process. And as a result of one expert not participating in this weighted average process, the number of weights and the number of selected experts in the gating process, the routing process, is reduced by one. So uh, there is always going to be one expert, which is one feed-forward network that constantly produce output, unweighted outputs, while the rest of the selected, the entire mixture of expert mechanism is still functions exactly the same as the G-shard approach. And so we have already developed that kind of a general sense of how the mixture of expert is different from the G-sharp project. And we are going to again verify that heuristic or that overview by looking at the code of it, and still applying the same logic. You should also go to the most meaty part of the entire code base, which means a top-down approach. We want to look at the very top module, which is the base model class, the DeepSeek MOE module. And as you can see here, the identity makes a copy of the input hidden states. And if there is a shared expert, the output of the shared expert on the hidden states get exactly added to the output of the MOE infer module, which is the output of the mixture experts, the mixture of experts modules. So that pretty much just verified what we have just observed. And after all, um, I hope you really get the gist of it, in that by applying the following principles in the fashion that I have just demonstrated to you, you actually can go right into the latest topic, the very latest, the most popular discourse on X.com, of the entire AI research community, with like very minimum prerequisite knowledge. The all you need to know, all you have known, as I assume that probably you only have seen a couple of model architecture .py file that has this kind of architecture, which is also why I emphasize that you probably need to get an overview of on those things, or otherwise you probably just get um, daunted by the lengthy code, or just so many lines of code. Jeez, dude. The other part is you need to like make good use and know how to read your diagram, and have like an idea of what the transformer diagram is. And with those, just those three pieces of knowledge, and by applying the principles, the following principles, you actually just get a very, like, I would say 80% of um, the like the most important information out of the Deepseek MOE project. And there are definitely a lot of details. There are many people explaining um, the detailed implementation, because, in fact, the mixture of expert modules, the most significant part is that it gets to be distributed and model paralleled into a lot of multiple GPUs. A lot of times it's hundreds of GPUs. But you're just getting started. You do not want to go all the way to the most detailed part. The only part you want to know when you have almost close to zero background knowledge on a particular topic is really just an overview like this. So that has been what I have wanted to demonstrate to you in the video, and hope you guys enjoyed it, and leave a comment um, on what do you guys want to see next time. I will be pumping videos every week. At the moment, it seems that I can still do that, and there are also a lot of other interesting topics to cover. And also, if there's anything you think there's an issue or some problems or some things I can improve, leave a comment as well. And if you think this kind of tutorials walkthroughs is very valuable, maybe hit your like button and share this link to your fellow researchers, and let them know this kind of approach um, actually exists. And I genuinely want to help more people to get hands-on approach to this, not in that um, more like bottom-up approach, but more a more top-down approach. And yeah, and see you guys next time. Ciao.